Imagine gazing into the night sky, searching beyond the familiar constellations, the gentle arc of the Milky Way, and the faint glow of distant stars. To the naked eye, the universe seems vast but scattered, tiny points of light against an endless black canvas. But hidden within that darkness are cosmic giants so enormous, so far beyond our scale of comprehension, that they stretch across millions of light-years, dwarfing everything we thought we knew about galaxies. One of those giants has recently been revealed, a discovery that changes our understanding of just how colossal the universe can be. Its name is Alcyoneus, and it is the largest radio galaxy ever detected. At first glance, Alcyoneus doesn't look like much. If you were to observe it in visible light, it would not appear dramatically different from countless other galaxies scattered across the cosmos. Its stars do not blaze any brighter, nor does its shape immediately announce its record-breaking size. Instead, its true nature is hidden in a wavelength of light invisible to our eyes, the strange, ghostly glow of radio waves. Through the lens of powerful radio telescopes, Alcyoneus reveals itself as something staggering, a cosmic colossus stretching some 16 million light-years across, larger than any radio galaxy ever discovered before. To put this into perspective, our own Milky Way is about 100,000 light-years across. Even the largest galaxies we commonly think of, like Andromeda, span only a few 100,000 light-years. Alcyoneus isn't just bigger, it's on an entirely different scale. Its radio lobes extend so far into space that they would stretch across hundreds of Milky Ways placed end to end. This isn't just a galaxy. It's a structure that redefines what we imagine a galaxy can be. Before we dive deeper into what Alcyoneus truly is and why its discovery is so significant, I'd like to invite you to settle in with us here at the Sleepy Minds. If you enjoy drifting through the mysteries of the cosmos, exploring the science behind the unseen, and discovering the quiet wonders that fill our universe, consider subscribing. Your support helps us continue bringing you these calm journeys into science, and it ensures you never miss the next hidden story the universe has to tell. Now, let's return to Alcyoneus. Radio galaxies are not new to astronomy, but their scale and beauty continue to surprise us. Unlike normal galaxies that we see shining with the light of their stars, radio galaxies are defined by their enormous jets of energy and plasma, launched from the supermassive black holes at their centers. These jets, traveling near the speed of light, shoot out into intergalactic space and inflate massive lobes of radio emission on either side of the galaxy. Over millions and sometimes billions of years, these lobes can grow to unimaginable sizes, forming cosmic structures that stretch far beyond the boundaries of their host galaxy. Alcyoneus is one such galaxy, but on an unprecedented scale. Its central black hole feeds these colossal jets, and the lobes extend across such vast distances that they challenge our sense of proportion. Imagine something that began at the heart of a single galaxy, jets of invisible plasma, stretching outward until they carve a shape larger than entire clusters of galaxies. That is what Alcyoneus represents. The sheer power of black holes, scaled up to a size that makes even the largest galaxies appear small. But what makes this discovery particularly fascinating is not just its size, but the subtlety of its existence. Alcyoneus was not immediately obvious. It does not sit in some extraordinary part of the universe, nor does it appear to have an especially massive black hole compared to others of its kind. In many ways, it is ordinary, and yet, Its radio lobes extend farther than any ever observed. This raises questions. Why this galaxy and why here? What unique circumstances allowed it to grow so vast when others did not? The answer may lie in the environment that surrounds Alcyoneus. Astronomers believe it resides in a region of space with exceptionally low density, meaning that there is less intergalactic matter to slow down or confine its jets. Like smoke drifting more freely in open air, the plasma lobes of Alcyoneus have been able to expand with little resistance, stretching farther and farther across the void. Over time, with nothing to stop them, they became the largest radio structures we have ever seen. This discovery was made possible by the low-frequency array, or LOFAR, a vast network of radio antennas spread across Europe. Unlike a single telescope, LOFAR combines signals from thousands of antennas to create one of the most sensitive radio instruments ever built. With this tool, astronomers can detect faint radio emissions that would otherwise remain invisible. It was through LOFAR's patient mapping of the sky that Alcyoneus was finally revealed, its ghostly radio glow emerging like a hidden giant from the cosmic background. What makes this so breathtaking is the reminder that the universe still holds secrets, even in the nearby cosmos. Alcyoneus is not on the edge of the observable universe. It is relatively close in cosmic terms, about 3 billion light-years away. That may sound distant, but compared to galaxies at the farthest reaches of the universe, it is practically in our neighborhood. And yet, until recently, this colossal structure went unnoticed, hiding in plain sight. It makes us wonder, if something this vast could remain unseen for so long, what other giants still wait in the darkness, waiting for our instruments to catch their faint signals? As we continue to explore Alcyoneus, its size becomes not just a number, but a symbol of the universe's ability to surprise us. 16 million light-years across. Numbers so immense they lose meaning when compared to our daily experience. But when we pause and consider, when we imagine the entire Milky Way as a small spark within its span, we begin to glimpse the scale of this cosmic marvel. And that is just the beginning of its story. To understand why Alcyoneus is so extraordinary, we first need to step back and examine what makes a radio galaxy in the first place. At the heart of nearly every large galaxy lies a supermassive black hole, often millions or even billions of times the mass of our Sun. These black holes are not merely silent, devouring objects. When matter spirals toward them, drawn in by their gravity, it doesn't simply vanish into darkness. Instead, the matter forms an accretion disk, an enormous whirlpool of gas and dust that heats up as it spins at incredible speeds. In the chaos of this environment, something remarkable happens. Instead of everything falling in, some of the material is redirected. Magnetic fields twist and coil, focusing energy into narrow beams that blast outward from the poles of the black hole. These are the relativistic jets, the engines that power radio galaxies. Traveling at nearly the speed of light, these jets push through interstellar and intergalactic space, carrying vast amounts of energy with them. Over time, these jets inflate enormous bubbles on either side of the galaxy, structures known as radio lobes. To radio telescopes, these lobes shine brightly, emitting radio waves that stretch across millions of light-years. They are, in essence, the footprints of a black hole's activity written across the canvas of the universe. For most galaxies, these lobes are immense but still within a scale that makes sense compared to the host galaxy itself. But Alcyoneus defies that pattern. Its radio lobes extend so far that the galaxy at its center is almost lost in comparison, like a tiny spark at the heart of a vast glowing cloud. This is what makes Alcyoneus unique. It demonstrates that under the right circumstances, the influence of a black hole can extend to truly cosmic proportions. What's even more intriguing is that Alcyoneus doesn't appear to have the traits we might expect from such an extreme example. Its central black hole is not unusually massive compared to others we've studied. Its stars don't show extraordinary signs of activity, and the galaxy itself isn't in a particularly dense region of space. In many ways, it looks average, and yet, its radio lobes are the largest we've ever found. This challenges our assumptions about how galaxies like this grow. Astronomers once believed that only the most powerful black holes, in the most energetic galaxies, could produce such enormous structures. But Alcyoneus suggests otherwise. It hints that environment might matter more than we thought. Perhaps its location in a relatively empty part of the universe gave its jets room to expand freely. With little resistance, the plasma streams could stretch farther and farther, gradually building a giant that now spans 16 million light-years. But there is also the element of time. Structures like Alcyoneus are not built overnight. They take hundreds of millions, even billions of years to form. Each lobe grows as new plasma is injected, expanding outward, cooling, and fading, while more plasma flows in behind it. Over cosmic time, this steady activity can inflate lobes that reach incomprehensible scales. Alcyoneus, then, may simply be the product of persistence. A black hole that has been steadily at work for eons, sculpting the universe around it in slow, quiet grandeur. The discovery also forces us to consider how common or rare such giants might be. If Alcyoneus exists relatively close to us in cosmic terms, could there be others like it waiting to be seen? Perhaps we have missed them, hidden in the faint background noise of the sky, detectable only with instruments sensitive enough to pick out their subtle glow. LOFAR's success in finding Alcyoneus suggests that with more surveys and deeper scans, more colossal radio galaxies may come into view. Another fascinating aspect of Alcyoneus lies in what it tells us about black holes themselves. We often think of black holes as destructive, consuming everything in their path. But galaxies like this remind us that black holes are also creators of structure. Their jets sculpt intergalactic space, distributing energy and matter on scales far larger than their host galaxies. Without such activity, the cosmos might look very different. Galaxy clusters, star formation, even the large-scale structure of the universe may all be influenced by these colossal outflows of energy. And yet, Alcyoneus stands as an outlier. It does not fit neatly into our models. Its existence raises new questions. How did it maintain such long-lived activity? What keeps its jets stable over such immense timescales? Why here in a galaxy that otherwise seems ordinary? Each of these questions pushes astronomers to rethink what they know about galactic evolution. For now, Alcyoneus remains a reminder of humility. The universe does not always conform to our expectations. Just when we think we understand its limits, it reveals something larger, stranger, and more mysterious than before. 16 million light-years across. A single galaxy shaping a region of space so vast that it strains the imagination. And this is not just a matter of scale. Discoveries like Alcyoneus deepen the mystery of cosmic feedback. the complex dance between black holes, galaxies, and the intergalactic medium. Understanding how energy flows from the heart of a galaxy into the vastness beyond is one of astronomy's greatest puzzles. Alcyoneus is both a clue and a challenge, urging us to look deeper, to refine our instruments, and to remember that the cosmos still holds secrets waiting for those patient enough to listen. As we continue exploring, Alcyoneus becomes more than a name. It becomes a symbol of discovery, a whisper from the universe that says, "There is more here than you can imagine." And with every improvement in our ability to see, more giants like this may rise from the darkness, reshaping our understanding of what galaxies truly are. Alcyoneus might be the largest radio galaxy we've ever found, but it is not the first to stretch our imagination. For decades, astronomers have cataloged so-called giant radio galaxies, structures extending over millions of light-years. These cosmic titans are rare, yet each discovery has pushed the limits of what we thought possible. Before Alcyoneus, one of the largest known examples was a galaxy called 3C236, which spans roughly 15 million light-years. Others, like Hercules A and Centaurus A, are famous for their striking radio lobes and dramatic jets, though they fall short in size compared to this newest discovery. What makes Alcyoneus remarkable is not only that it surpasses the previous record holders, but also that it does so without appearing unusual in other respects. In Hercules A, for example, the central black hole is among the most powerful known, unleashing jets of extraordinary brightness. In Centaurus A, the galaxy is close enough to us that we can observe its details in remarkable resolution, including the turbulent interactions between its jets and surrounding material. But Alcyoneus is different. It does not blaze with unusual energy, nor does it dominate its environment in obvious ways. It is almost understated, quietly becoming the largest of its kind without drawing attention, until now. This comparison highlights a crucial point. The universe has many paths to grandeur. Some galaxies achieve notoriety through power and intensity. Others, like Alcyoneus, achieve it through persistence and subtlety. Over time, the slow, steady outflow of energy can carve out something as monumental as the largest radio galaxy ever seen. But what does it mean to be a radio galaxy in the first place? To answer that, we need to pause and think about the nature of radio waves themselves. When most people hear radio, they think of music stations or signals bouncing from towers to car antennas. But in physics, radio waves are simply one part of the electromagnetic spectrum, the same family of radiation that includes visible light, X-rays, and gamma rays. The only difference is their wavelength. Radio waves are much longer, often stretching from centimeters to meters, or even kilometers, compared to the tiny wavelengths of visible light. This longer wavelength gives them unique properties. They can travel vast distances without being easily scattered. They can penetrate dust clouds that block visible light, revealing hidden structures otherwise invisible. And when high-energy particles, like the electrons spiraling through Alcyoneus's jets, move through magnetic fields, they emit a special kind of radiation called synchrotron emission. It is this process that lights up the colossal radio lobes, making them visible to our instruments. To our eyes, the space around Alcyoneus might look like a quiet darkness, punctuated only by the faint glow of distant galaxies. But to a radio telescope, it becomes something entirely different. Enormous arcs of energy sweep outward, shining like ghostly wings that dwarf the galaxy at their center. The discovery of Alcyoneus is a reminder that what we see with our eyes is only a fraction of reality. The universe is broadcasting countless stories in radio waves, waiting for us to listen. In the past, our ability to hear those stories was limited. Traditional radio telescopes, powerful though they were, could only map the sky in small portions or with limited sensitivity. Structures as faint and extended as Alcyoneus might have been missed, their signals blending into the background noise. But new instruments like LOFAR have changed that. By linking thousands of antennas across Europe, astronomers have created a radio eye of extraordinary precision. With it, they can not only detect faint emissions but also map them in exquisite detail, revealing structures that stretch farther than we ever imagined. This technology is not just about one discovery. It marks a turning point. If LOFAR can reveal Alcyoneus, then it stands to reason that there may be many more like it, scattered across the cosmos. Some may be even larger. Some may be stranger, shaped by environments or histories unlike anything we've yet imagined. Each new detection will help piece together the puzzle of how galaxies grow, how black holes influence their surroundings, and how the large-scale structure of the universe evolves. For astronomers, Alcyoneus is both a marvel and a tool. By studying its radio lobes, scientists can probe the intergalactic medium, the thin, diffuse matter that fills the space between galaxies. These lobes act like cosmic weather vanes, their shapes influenced by the environment through which they expand. By analyzing their curves, brightness, and distribution, astronomers can infer details about regions of space otherwise invisible. In this sense, Alcyoneus becomes not just an object of study, but a probe into the hidden fabric of the universe. There is also a philosophical dimension to this discovery. For centuries, humanity has measured greatness in terms of proximity and visibility. The stars we see, the galaxies photographed in dazzling color, the clusters mapped by visible light, they form the tapestry we imagine when we think of the cosmos. But Alcyoneus is a reminder that true giants do not always stand in the spotlight. Some lie in the quiet shadows, whispering their presence in wavelengths we cannot see. It took patience, technology, and curiosity to uncover this giant, and that lesson will guide us as we continue to explore. Looking forward, the discovery of Alcyoneus is only the beginning. New instruments, like the square-kilometer array currently under construction, promise to expand our vision even further. When complete, it will be the most powerful radio telescope in history, capable of detecting even fainter and more distant radio structures. What might it reveal? Perhaps galaxies larger than Alcyoneus, or patterns in their distribution that point to new physics. Perhaps entire classes of objects we do not yet have names for. The universe has a way of rewarding those who listen in new ways. For now, Alcyoneus stands as the record holder, a quiet giant that outshines all others in scale. It is a reminder that the cosmos is far vaster than our imagination often allows, and that each discovery is a doorway to new mysteries. 16 million light-years of glowing plasma, born from a black hole in an ordinary-looking galaxy, stretching into the darkness like a silent monument. A monument not just to the power of nature, but to the power of discovery. When we look at Alcyoneus, it is easy to be captivated by its size alone. 16 million light-years across, its radio lobes stretch farther than anything we have measured before. But the true importance of such a discovery lies not only in the numbers, it lies in what galaxies like this can teach us about the universe itself. Radio galaxies are not merely strange curiosities. They are fundamental actors in the cosmic drama, shaping their surroundings in ways that ripple across billions of years. At the heart of this influence is energy. The jets produced by supermassive black holes are among the most powerful phenomena in the cosmos. Imagine streams of plasma moving at near-light speeds, carrying more energy than millions of suns combined. When these jets smash into intergalactic space, they don't simply fade away. Instead, they transfer their energy to the medium around them, heating it, pushing it, and stirring it into turbulent motion. This process, often called feedback, has profound consequences. In galaxy clusters, the vast congregations of hundreds or thousands of galaxies bound together by gravity, the space between galaxies is not empty. It is filled with a thin, hot gas called the intracluster medium. Left alone, this gas would gradually cool, condense, and trigger the formation of new stars. But radio galaxies prevent this runaway star formation. Their jets reheat the gas, keeping it from cooling too quickly and regulating the growth of galaxies within the cluster. In other words, radio galaxies act like cosmic thermostats, balancing the temperature of the universe's largest structures. Alcyoneus, with its immense size, may be a particularly vivid example of this role. Its lobes stretch so far into space that they likely influence not just the immediate environment of its host galaxy, but also the larger-scale structure of matter around it. By injecting energy over such vast distances, it becomes part of the story of how galaxies and clusters evolve. Understanding Alcyoneus, then, is not just about marveling at its scale. It is about tracing the flow of energy across cosmic space. This perspective brings us to one of the greatest puzzles in modern astronomy: the cosmic web. On the largest scales, the universe is not random or uniform. Instead, matter is organized into a vast network of filaments and voids. Galaxies gather along the filaments, where dark matter has drawn them together, while enormous empty regions stretch between them. This web is the skeleton of the universe, shaped by gravity over billions of years. Radio galaxies like Alcyoneus may help us map this cosmic web. Their lobes expand through intergalactic space, and their shapes are influenced by the environment they encounter. If they grow in a dense region, the lobes may be confined, bent, or distorted. If they grow in a void, they may stretch freely, forming the vast structures we see in Alcyoneus. By studying the distribution and orientation of radio galaxies, astronomers can learn about the hidden scaffolding of dark matter that underlies the visible universe. What makes Alcyoneus particularly fascinating is its apparent location. Astronomers believe it sits within a filament of the cosmic web, a thread of matter connecting larger nodes of galaxies. This placement may explain its unusual growth. In a filament, the environment is less crowded than in a cluster, giving the jet space to expand. Yet it is not completely empty, meaning there is still material to interact with, feeding and shaping the lobes over time. The result is a structure that both reflects and reveals the architecture of the cosmic web. Studying Alcyoneus also sheds light on the mysterious balance of forces in the universe. On one hand, gravity pulls matter together, forming galaxies, stars, and planets. On the other, energy from phenomena like radio jets pushes outward, preventing collapse and spreading material across space. The interplay of these forces is what gives rise to the universe as we see it. Too much gravity, and everything would condense into massive clumps. Too much feedback, and matter would disperse, preventing galaxies from forming. The cosmos exists in a delicate equilibrium, and Alcyoneus is a vivid demonstration of that balance in action. There is also a practical reason to study galaxies like this. They act as cosmic laboratories. The physics of plasma, magnetic fields, and relativistic jets are incredibly difficult to replicate on Earth. No machine we can build produces scales or energies that rival what happens around a supermassive black hole. But by observing Alcyoneus, astronomers can test theories of plasma physics under extreme conditions. Its lobes, shaped by magnetic fields and particle flows, become natural experiments written across millions of light years. This has ripple effects for other fields of science as well. Understanding how particles move through magnetic fields informs not only astrophysics but also our understanding of cosmic rays, high-energy radiation that regularly strikes Earth. These rays originate from sources like supernovae and black hole jets, and studying structures like Alcyoneus helps us trace their origins and behavior. In a very real sense, what happens in distant galaxies can affect the conditions of our own planet. But perhaps the most striking lesson of Alcyoneus is the reminder of scale. 16 million light-years, numbers like this can feel abstract, but when we pause to consider them, the immensity is staggering. If we were to travel at the speed of light, the fastest speed possible in the universe, it would take 16 million years just to cross from one end of this galaxy's lobes to the other. That is longer than the age of the entire human species. In fact, when Alcyoneus first began forming its colossal lobes, our planet may still have been home to some of the earliest ancestors of life itself. The story of Alcyoneus, then, is also a story of time. It is not just large in space, it is vast in duration. Its existence stretches across epochs, reminding us that galaxies live on timescales we can barely comprehend. When we study it, we are glimpsing processes that unfold over billions of years, each lobe a monument to patience and persistence written in plasma and light. So as we consider Alcyoneus, we must remember that its significance goes beyond records and measurements. It is a key to understanding how galaxies evolve, how the cosmic web takes shape, and how energy flows across the largest structures in the universe. In its silent, ghostly glow, we see not only the power of a single black hole but also the interconnected story of the cosmos itself. When we step back and consider the vastness of Alcyoneus, it's easy to feel small. A galaxy so enormous, stretching 16 million light-years across, can make our planet, our entire solar system, seem like little more than a speck of dust floating in the dark. But discoveries like this do more than humble us. They expand the boundaries of what we know, reminding us that the universe is deeper, more intricate, and more mysterious than we once believed. Alcyoneus is not just a scientific curiosity. It is a symbol of patience, persistence, and perspective. For hundreds of millions of years, its black hole has been quietly sculpting space, inflating radio lobes that reach far beyond its stars. It never announced itself with fireworks or drama. It simply grew step by step until it became the largest structure of its kind we have ever seen. In that quiet, steady growth, there is a lesson for us as well. The universe does not rush. It does not measure time as we do in days or years. It measures in eons, in the slow unfolding of cosmic events that span billions of years. When we study Alcyoneus, we are peering into that timescale. We are glimpsing a process so vast that it dwarfs human history. The pyramids, the rise and fall of civilizations, the entire span of recorded history. All of it is a fleeting moment compared to the age of Alcyoneus's glowing lobes. And yet, here we are, fragile beings on a small blue planet, able to detect it. That is perhaps the most remarkable part of all. Out of the countless forms of life the universe may hold, we are among the few, maybe the only, capable of looking up, building instruments, and uncovering secrets hidden in the radio sky. In discovering Alcyoneus, we prove that even the smallest observers can reveal the grandest truths. This is the paradox of astronomy. On one hand, it makes us feel tiny. On the other, it grants us an almost infinite horizon. We may be small, but our curiosity is vast. The same curiosity that once mapped the stars by firelight has now built arrays of antennas spread across continents, reaching into invisible wavelengths to reveal cosmic giants. In Alcyoneus, we see not just the power of black holes, but the power of human imagination. There is also a quiet beauty in the fact that Alcyoneus is invisible to us without the right instruments. To our eyes, it would appear ordinary, unremarkable, just another galaxy among billions. Only when we shift our perspective, when we look with radio telescopes, does its true form emerge. This reminds us that reality is always more layered than it first appears. What we see is only one version of the truth. Beneath the surface, there are hidden worlds, hidden structures, hidden giants. How many more Alcyoneus-like galaxies are out there? How many immense structures are waiting, faint and ghostly, beyond the reach of our current tools? Each new discovery widens the horizon, suggesting that the universe holds more than we ever dared to imagine. Perhaps Alcyoneus is not an exception but a glimpse into a category of cosmic giants we have only just begun to notice. The more we look, the more the cosmos answers, and the more it whispers that the answers will always lead to deeper questions. As we close our journey into this discovery, consider what it means for us here on Earth. In the daily rhythm of life, we measure our importance through personal struggles, human history, the things closest to us. But when we lift our gaze and reflect on a galaxy that stretches millions of light years, we are reminded that our story is part of something larger. The atoms that make up our bodies were forged in ancient stars. The curiosity that drives us is the same force that leads us to uncover giants like Alcyoneus. We are not separate from the cosmos, we are its way of knowing itself. Perhaps that is why discoveries like this are so moving. They are not just scientific footnotes or numbers to record. They are moments of connection. When we look at Alcyoneus, we are looking at the universe telling us, there is more to see, more to learn, more to understand. It invites us to expand our perspective, to live with wonder, and to embrace the mystery that lies beyond the edge of sight. And so, as Alcyoneus stretches silently across the darkness, let us remember that we, too, are part of this unfolding story. We may never travel its length, but we can carry its lesson, that the universe is vast, that time is deep, and that knowledge is always waiting just beyond the horizon.